Okay, so today we're going to do pages for Chapter 5 and Chapter 6. So let me zoom on in here. So here, notice in the instructions, it says to classify the triangle by its side lengths and by its angles. So for this one, we can see that all sides are the same. So this tells me that this triangle is equilateral. And then you could have either, for the name for the angles, if you realize that when all sides are the same, then also all angles are the same. So you could have said that it's also an equiangular. Or if you realize that they're all the same and you know that the three angles of a triangle add up to be 180, and when you divide them, you're going to realize that all three angles are going to be 60 degrees, making this an acute triangle. So the name for the angle measures could have either been equiangular or acute, but for the giving it its name based on its sides, it's equilateral. For the next one, we can see based on its angles, it's got a right angle here, so this would be a right triangle. And then I know they didn't add congruency marks. However, all of the sides appear to be different. So this would be a scalene triangle. And then the next one, they did give us congruency marks, making this isosceles, two sides the same. And then this angle looks larger than 90 degrees, making it obtuse. So if I give you a question like this, it'll be obvious with either numbers or congruency marks. You won't have to assume. And here we know that the three angles of a triangle add up to be 180. So I'm just going to add the two angles they gave me. 30 plus 80 is 110. Subtract that from 180. And the missing angle, or what x equals, is 70. For the next one, I can do this two ways. I could still use that triangle sum. I can add 2x plus x plus the right angle, set it equal to 180. We also learned a corollary that stated that the two acute angles of a right triangle are complementary. So that means that they add to 90. So I could also solve for x this way as well. So if I do it the first way, I'm going to add my x's, subtract my 90. 3x equals 90, divide by 3, and x equals 30. Same thing if I did it over here. I would just get 3x equals 90, divide, and x equals 30 either way. And then for this one, we had to realize that we have a right angle here. Not a right angle, actually a vertical angle. So then what we could do here is just go ahead and add the two we have, the 55 plus the 50. If we wanted to find the x in this one, and then get 105, subtract that from 180, and the missing angle, or x, is 75 degrees. We didn't need to use that right angle. Now, the next one, this is where we learned about congruent polygons. So we actually have a congruent quadrilateral here. So DEFG, this one is congruent to this one, the WXFG. I'm going to use my congruency statement so I know what sides to match. So notice here, I've got side DG here. This bottom one, where the 10 is going to be set equal to WG, which is this one right here. So to find x, I'm going to do 3x minus 5 equals 10. I'm going to add 5. 3x equals 15. Divide by 3, and x equals 5. Now for the y, again, I could match these angles here. So notice the two angle G's are going to match, which is this one right here and this one right here. So I'm going to set 5x plus, or 15x plus y equal to 90. And then I can't solve it with two variables, but just like on the last test, they told me that x equals 5. So I'm going to go ahead and plug in 15 times 5 plus y equals 90. 75 plus y equals 90. Subtract 75, and y equals 15. Good there? All right, so the two answers were 5 and 15. Then for the next one, it says, decide whether the triangles can be proven by the given postulate, so by side, angle, side. So I've already got two sides that are marked, two side pairs. I could also bring in the vertical angle pair. So then this one is yes, because I've got a side and a side, an angle and an angle, and a side that match. So this is yes. You would just have to add in the vertical angle pair. For the next one, I could prove this by side, and then I could also go back and say CPCTC and show that all these angles are also congruent. So yes, I could use angle, side angle as well. I could actually use every single shortcut. Then number 11, I could add into my proof my reflexive side. And yes, this could be proven by side. So this is a yes. Pretty good there? All right, next one. I'm going to skip 12. I'm going to do 13 first, and then I'll go back and do the proof. So for 13, it was actually two separate questions. So they wanted to know what we needed to add to the picture to be able to prove the two yellow triangles are congruent by hypotenuse leg. Right now, the only thing I can see is I have two right angles, so I can potentially be doing hypotenuse leg. My hypotenuses are marked, but my legs are not. So I would need to either have stated that PQ is congruent to TS or ST, or that this other leg was congruent to this other leg. So the other statement that I would needed to have added was either stating that QP was congruent to TS, which is one of the leg pairs, or QR congruent to TU. Either one on those. Then in order to do the same picture and use angle, angle, side, I would have needed to, and let me come back over here, erase. So right now I have an angle that's marked. I've got an angle, maybe I'll do it in green, an angle and a side. So I either need to mark this angle congruent to this angle, or that this angle is congruent to this. And then I would have had an angle, angle, side, or if I did it this way, I would have had an angle, aside. So what I needed to state was, in order to use that, would have been angle P congruent to angle S, or angle R congruent to angle U. That's what I would have needed to use angle, angle, side. Now I'm going to do the proof. So in this picture, let's see. I set up my statements. And my reasons. So I'm going to go ahead and state the given. That triangle ABC is isosceles with base AC. And then BD bisects angle B, so that was given. So I need to be able to show that these two triangles, this one is congruent to this one. So the first thing I could do is use the fact that I have an isosceles triangle. And by definition of isosceles triangle, since AC was the base, this tells me that AB is going to be congruent to BC. So I could state that AB is congruent to BC, and this would be definition of an isosceles triangle. Then the third one. So far, I could also bring in the fact that since the angle was bisected, BD bisects angle B, then that tells me that this angle is congruent to this. We could have also used the base angle's converse as well. It doesn't matter. But I'm going to use the fact that the angle was bisected. So I'm going to state that angle ABD is congruent to angle CBD. And this is definition of an angle bisector. Yes. The next thing I'm going to do, because right now I just have a side and an angle, I'm going to do the reflexive side and say that BD is congruent to BD, and that's reflexive. And then now I have enough information to use side angle side. Good. So triangle ABD is congruent to triangle CBD, and the reason would be side angle side. I would definitely pay attention to the triangle proofs for the midterm. Okay. All right, that is it for chapter 5. Let's go on to chapter 6. So here it says 2 midsegments of triangle ABC are DE and DF. So it wants me to find the length of DB. So remember, point D here is the midpoint. So if this is a midpoint, I know that AD and DB are going to be equal. So this would be 10. Then I also can see that DF is right here, and it's parallel to BC, and the length of BC is 26. So to find DF, I just divide it by 2, and it's 13. If I were to connect EF, this would be the mid-segment to AB. So that's what I can conclude about EF, that it's a mid-segment. For number 4, it wants us to find the value of x. So for here, I can see that okay, so for the next one, we can see that this is a perpendicular bisector. So I know that any point on the perpendicular bisector is going to be equidistant from these endpoints. So I'm going to set 2x plus 11 equal to 8x minus 1. I'm going to combine my x's. Negative 6x plus 11 equals negative 1. Subtract 11. Negative 6x equals negative 12. Divide by negative 6, and x equals 2. For the next one, same thing, but this is an angle bisector, the QS. So again, I know that any point on that angle bisector is going to be equidistant from the sides of the angle. And I can tell that their distances by the right angles. So I'm going to set 6x equal to 3x plus 9. Subtract 3x. 3x equals 9. Divide by 3, and x equals 3. Number 6, same thing. This time we're looking for the angle measures. We can tell that they were bisected because of the congruent distances here. So I'm just going to set 5x minus 4 equal to 4x plus 3. Going to subtract the 4x. X minus 4 equals 3. Add the 4, and x equals 7. Now, for the next one, it says in exercise 4, is point D on the perpendicular bisector of SU? And yes, it is, because we can tell of the congruency parts and that it's equidistant. Then for number 8, I'm not going to give you a question like this where you have to use, for this one you would have needed to use Pythagorean theorem. You're not going to need to do that. What might have happened if you get a question like this is I might tell you that the length of AD is going to be 7. And then you would know that all of these blue segments were congruent, so the length of DB would also be 7. What they expected you to do was actually do Pythagorean theorem to find the length. And we haven't learned it. We're going to learn it after Christmas. But a lot of Algebra 1 classes teach it to you. That formula is a squared plus b squared equals c squared. We're going to learn it in chapter 9. And what they would have expected you to do is do a squared plus 24 squared equals 25 squared. You will not have a question like this. I would give you the length of one of those blue ones, and then you would have just had to realize it was congruent. For the next one, this is the 2/3, 1/3. That's going to be the length of this centroid. So for the first one, they're giving us the length of LS, which is right here. And they told us LS, the whole thing, was 36. So this is going to be my 1/3 piece. This will be my 2/3 piece. So in order to find the length of PL, I know that PL is going to be 1/3 of LS. So if I put in the length of LS, it's 36. And 1/3 of 36, PL is 12. To find PS, I know that PS is going to be equal to 2/3 of LS. So 2/3 of 36 is going to give me, if I simplify diagonally here, make it a 12, PS equals 24. And then for the next one, number 10, they gave me the length of TP, which is right here. And they told me it had a length of 20. So I know that TP here, this is the 2/3 piece. And then over here on this side is the 1/3 piece. So if I go ahead and first find TJ, I know that TJ, the length of the whole thing, is going to be equal. So I can go ahead and, since they gave me I could do 2/3 of TJ equals TP. So I'm going to go ahead and replace what they gave me, which was the TP. It was 20. I'm going to divide by 2/3, which is really multiply by the reciprocal. Simplify. And the length of the whole thing is 30. So that's TJ. Then the fastest way probably to find PJ would just be to do 30 minus the 20 that they gave us, and PJ is 10. Then for number 11, this one is, they gave us JR, and JR is this one right here. And I know that J is the midpoint. So if JR is 25, then JS is 25, and then RS is 25 plus 25, and it's 50. So JS is 25, and RS is 50. Because the centroid goes from the vertex to the midpoint. Next one says, is it possible to construct a triangle with side lengths 9, 12, and 22? This is where you're going to take the two smaller numbers, you're going to subtract them, and you're going to add them. So when I subtract them, I get 3. When I add them, I get 21. And because 22 is not in between 3 and 21, I would say no. You cannot, because it does not fall in between the range. Yes?
And for that one, they also can't be exact, right? Like it can't be like 3 or 20.
Correct. It can't equal those, exactly. So what we would be looking for is a side that's in between 3 and 21. All right, then the next one, it says, if the measure of angle JKM, which is here, is going to be greater than LKJ, or LJK, yeah, LJK, this one. So in order to do this, to make it easier for maybe me to see, I'm going to say this one's 100 because it's a bigger number, and let's say this one's 80. And then if it wants me to compare the sides, this is where I'm going to look across, and the side that's across from the bigger angle, which is 100, is the bigger side. So that would make MJ the longer side. So that side's bigger. Then if I do the same thing and I want to compare the angle measures, this time they gave me the side lengths. So if I erase this, and they told me that MJ was smaller. So let's say I give this one an 8 and then LK is bigger. Then that tells me that the angle across from it, this LKJ, this one's going to be the longer angle, or the larger angle, because it's across from the 10. The other angle they were asked to compare was the JKM, which was this one. And then the last one says to describe the range of possible distances from the beach to the movie theater. So it wants this side of the triangle. So the same thing I did on number 12, I'm going to add and subtract the numbers. Oops, sorry, that should be a 7. I already went to the answer. 9 minus 7 is 2, and then 9 plus 7 is 16. So the distances are going to be any number that's in between 2 and 16, and it cannot equal 2 or 16. So that was it for the last page. Again, you have one more page in the study guide to complete for tomorrow.